Okay, wonderful. So we are live. So a rotation turns a figure around a fixed point. For today's lesson, we're going to be talking about rotating around the origin. So a pre-image in the coordinate plane that will be rotating around the origin. Tomorrow and later in the week, we'll talk about rotating an object around a point other than the origin. So today we're just focusing on around the origin. Now, here we have a bunch of clockwise rules for rotation. So we're actually going to talk about 3 different ways to rotate. We'll have rules. If you don't like memorizing rules, I'll give you a method where you physically rotate your paper. If you don't like that, then you have using slopes as an option as well. So 3 different ways to look at rotations. Now, for the purpose of our class, if we're not giving you a direction, so for example, do you see how number 1, it just says 270 degrees? It doesn't tell you clockwise or counterclockwise. So if there's no direction given to you, it's assumed to be counterclockwise. Now, a lot of students don't use regular clocks, so I know this seems silly, but I'm actually going to draw 12, 3, 6, and 9. Counterclockwise would be going from 12 to 9, 9 to 6, 6 to 3, 3 to 12. That's counterclockwise. I don't know if you can fit that in there. Which sometimes I just abbreviate to CCW, counterclockwise. You might want to write this down, especially those of you that rely more on digital clocks, because you don't, you need to know the direction in order to know which way you're turning. So then going from 12 to 3 to 6 to 9, like a normal clock, like the clock on our wall in our classroom, is just clockwise, or what I like to abbreviate as CW. So we have counterclockwise and clockwise. Now, if I'm turning something 90 degrees counterclockwise, that's the same as going 270 degrees clockwise, right? So, for example, 12, 6, no, just kidding. 12, 3, 6, 9. So just to kind of give you an idea here, right? I'm just using a Post-it to show you. But a quarter turn, this is like normal orientation. I'm going to call this portrait. A quarter turn, right? So if I'm going 90 degrees counterclockwise, a quarter turn means that I would go this direction. So that's 90 degrees counterclockwise. Okay? I'm turning it. 12 is going to 9. So that's a 90 degree counterclockwise turn. So notice what happens. 12 is on the left. Keep that in mind. If I turn this paper 270 degrees clockwise, so here's normal, 90 clockwise, 180 clockwise, 270 clockwise. Isn't that the same as what I just did, 90 counterclockwise, where 12 is on the left? So I'm just kind of proving a point here that rotating 90 degrees counterclockwise is the same as going 270 in the opposite direction. 180 degrees, it doesn't matter the direction. 180 turns it upside down. 90, 180. That was going clockwise. Or 90, 180, sorry, regular. 90, 180, that was going counterclockwise. Regardless, turning it turning 180 degrees turns your paper upside down. 270 degrees counterclockwise is the same as going 90 degrees clockwise. So, again, if I'm going 200, are you guys buying this, or do I need to show you again? Okay. So we're okay with these equivalent rotations going the opposite direction? Okay. So what we're going to do, you have all of these rules that you could use. If you're given a 240 degree clockwise rotation, what's happening here is that y is becoming negative. So if you think about it, here, right, the y becomes negative, x stays the same. 180, you're doing 2 quarter turns, if you think of it that way. So x becomes negative, y becomes negative. They stay in the same spot. So notice how 90 counterclockwise and 90 clockwise, y and x flip. 90 counterclockwise, right? If I draw a counterclockwise arrow, it points to the negative. 90 clockwise is the same as 270 counterclockwise. If I draw a clockwise arrow, it points to the negative. So that's a way to help you remember the rules. I personally am not a rules person because to me, memorizing doesn't necessarily make sense. So if you're not a rules person, we have a method for you. So for the bottom examples, we're going to use, oh, I just cut them off. The steps here, and we crossed out opposite, and we modified steps 3 and 4 to be step 3, record your ordered pairs. Step 4 was turn your paper back and graph the ordered pairs. Those of you watching this at home, you need to make those corrections on page 7. Those of you here, you did it as your warm-up. So now let's actually do that. So first thing we want to do is graph the original, the pre-image. So R is 3, 1. Here's R. S is 5, 1. There's S. T is 5, negative 3. That's T. And U is 2, negative 1. Let me try to make this a little clearer. Okay. So there's my picture, there's my pre-image, my object, my quadrilateral. So step 1, I graphed my original points. That's called the pre-image. Step 2, I'm going to turn my paper the number of degrees specified. I'm going to go in that direction. So we crossed out opposite. We're going to go in the direction given. Since no direction is stated, that means we're going counterclockwise. So we're doing a 240 degree turn counterclockwise. And I'm even going to put the clock here, or the 12, the 3, the 6, and the 9. So counterclockwise would mean that I'm going from 12 to 9. So I should be turning my paper, right? If that was my paper, I should be turning it to the left. Do you guys see how going from 12 to 9 is counterclockwise? Are we seeing that? Okay, let me zoom out so you can see my paper, hopefully. Whoop, too far. Okay, that's as much as you can, that's as much of the paper I can get into the view. So I'm going to actually, and you're doing it with me, you're going to physically turn your paper. Quarter turn is 90, upside down is 180, another quarter turn is 270, and I turned it 270 degrees counterclockwise. Do you want me to do it again? Did I lose you? Okay. So now I'm going to record my points according to my new coordinate plane. What do I mean by that? My new coordinate plane will be where these values above 0 and the y are positive, these values are negative, these values to the right of 0 are positive in the x, these values to the left of 0 are the negative x. So for example, my new ordered pair, R prime, is at positive 1, negative 3. Are you guys seeing how I'm using my new coordinate plane? Positive 1, negative 3. S is positive 1, negative 5. S prime is positive 1, negative 5. U prime is negative 1, excuse me, negative 1, negative 2. T prime is, hold on, 1, 2, negative 3, 1, 2, 3, 4, 5. Negative 3, negative 5. Did I lose anybody on how I got those points? Yes.
I don't understand. So aren't those the same points?
Yes, but they're according to our new coordinate plane, where now this is the x-axis, this is the y-axis. These values to the left of 0 are negative. These values to the left of right of 0 are positive. These y values are now positive. These y values are now negative. So they are the same points, but they're new according to how you rotated your paper and the positioning of the coordinate plane now. Where now here are my positive x's, here are my negative x's, here are my negative y's, positive y's. Are we okay on how I got those points? Okay, so that was step 3, recording the new ordered pairs. Now I'm going to turn my paper back to normal. This is normal. And I'm going to record those points. I'm going to use those points to graph. So now going back to my original coordinate plane, as if it were a normal piece of paper, right? Now I have my y-axis, my x-axis, exactly like it's labeled. I'm going to plot 1, -3. There's r prime. 1, -5 is s prime. -1, -2 is u prime. And -3, -5 is t prime. And I'm going to connect my dots to create my quadrilateral. The last thing you want to do, I don't have it listed as a step, but you should check this. So how can we check this? We want to make sure that this figure rotated 270 counterclockwise, which jog my memory. 270 counterclockwise is the same as what? Oh, I'm sorry, I'm writing it. Eden? Good, 90 clockwise. So to check this, I'm going to connect one of my points. Let's do point R. Connect R with the origin with R prime. What kind of angle did I just make? A 90-degree angle. Very nice. That checks out. What direction did R move to get to R prime? Clockwise. You see how 12 to 3, 3 to 6, eventually to 9, that's a clockwise move. That checks out. So that's how you can double check your work. Yes?
So what's the point of turning it if you can just like use the original points to make it into the
So you are using the original points, but think about how your coordinate plane is changing. So like what we were reading as 3, 1 to get to the original R, when you turn your coordinate plane, it really turns into 1, -3. Because you're reading the original points according to the new orientation of your coordinate plane when you turn it. Does that make sense? Okay. Yes?
But if you just use the thing where you change x, y to negative y, x, like for 90 degrees, why would you have to rotate?
So what I was saying is these are the rules to rotate. I'm showing you why they work by rotating your paper. So you could just use the rules and memorize them, but I find that a lot of students don't memorize things that don't have meaning. So some people like a method. This would be the method. Yeah?
What about like, how are you going to, like for any angle that isn't within the rules or that can't be like, with a 90-degree rotation?
Oh, so we only do 90, 180, or 270.
Oh.
Yeah, so you could use, eventually you could use like GeoGebra or technology to rotate in different, like a different angle measure. You could think about how 45 is half of 90, so you could do a half of a 90-degree rotation when you turn, but we only focus on 90, 180, and 270. Okay, so let's graph the next one. We have P is -5, -4. So there's our original P. Can you guys still see what I'm doing? Yeah. Okay, so there's P. Q is 2, -2. So again, just to reiterate, this method of turning your paper is instead of using the rules that are above. So you could memorize the rules and just do it that way, but if you're not a memorizing type of person, you have a method. Okay, so I graphed my original. Now, notice how with 180, the order doesn't matter. Or, sorry, not order. I'm thinking Math 8. The direction. I squeeze it in there. Direction doesn't matter. Let me fix this. Hold on. The direction doesn't matter because 180 degrees, right? I showed you. If you go clockwise 180, you end up upside down. If you go counterclockwise 180, you end up upside down. So 180 degrees, the direction doesn't matter because it's upside down. Okay, so flip your paper upside down. According to your new coordinate plane, where x's are positive over to the right x's are negative to the left, y's are negative below, and y's are positive above. Whoops, you can't see. Hold on. Okay, so I turned my paper upside down. I'm going to write my new points. P prime is going to be -5, -4. R prime is -1, +1. Hold on. Oh, wait. Hold on. That's 5 should not be negative. Whoa. Let me go back. Sorry. P prime is +5, +4. Sorry about that. I read it wrong. R is +1, -1. R prime. And Q prime is -2, +2. Am I losing you guys? Okay. Once you've written your new ordered pairs, you can turn your paper back to normal. And then you can graph these according to your regular coordinate plane. Now, if you don't like having the points upside down, you can take a Post-it, write your points on your Post-it, turn your paper, and then turn your Post-it back to normal. So that's another option. Yeah. Yes. I just didn't include Post-its because I'm worried you guys are going to lose them, and then without the Post-it, you don't know how you did this. So for the purpose of the notes, that's fine. On a quiz or test or classwork, I'll hand out Post-its to you guys. I can read upside down. So P prime is 5, 4. So I'm going to go over 5, up 4. Here's P prime. R prime is 1, -1. Up 1, over 1, down 1. Here's, hold on, let me move that. There's R prime, and it kind of is on itself. It's rotated onto itself. -2, +2 is Q prime. And then we can connect. All right, so how do we check this one? If you connect R through the origin with R prime, we make a straight angle. And how much does a straight angle measure? Jared?
180.
Yeah, a straight angle measures 180 degrees, so that's how we can check. It's a little blurry. How are we doing with physically rotating our paper? Okay, let's say that's not for you. If that's not for you, don't worry. I'm here to please. I got lots of methods. So if you don't like rotating your paper, maybe you like slopes. Maybe working algebraically is more your thing. So now notice here I gave you the direction. We're going 90 degrees clockwise. Jog my memory. What's equivalent to 90 degrees clockwise? Ara?
270 degrees counterclockwise.
Good. 270 counterclockwise is the same thing. Okay. So when we're using slope, the first thing we want to do, I'm going to label this the slope of OT. What do I mean by OT? I mean the slope going from the origin to point T. And I'm not simplifying any of my slopes. I want the raw movements, in other words. So here my slope, my rise is up 3, that's positive, left 2, that's negative. Now, a 90-degree angle means that I'm really dealing with a perpendicular slope, right? So the opposite reciprocal, right, I need to make this positive. The reciprocal of 3 over 2 would be 2 over 3. So my opposite reciprocal slope from the origin, I'm going to go up 2, right 3. There's T prime. Do the same thing for Z. So the origin from, the slope from the origin to Z, I went up 4 over 0. Now really, 4 over 0 is undefined, right? We're not going to simplify that because we want the movement. So the perpendicular to that, we're just simply going to take the reciprocal. And you can't really take the opposite of an undefined slope, right? It's not a number, so you can't make it this concept of being undefined. You can't do the opposite of undefined. So you kind of have to use a little bit of like logic here, I guess. So this point Z, you see how it's on the y-axis? If it's going a quarter turn, it's going to end up on the x-axis. I want it to end up on the positive x-axis over here, so that Z is moving 90 degrees clockwise to land on Z prime. Are you seeing how I'm using a little bit of the algebra of the movement, but also the geometry of where I'm going to kind of get that Z prime would be over here? Because the other option for it going 90 would be over here in the negative, and look, that would put T and Z really far away from each other when they're actually pretty close. And that would be that it's moving counterclockwise 90 instead of clockwise 90. Am I making sense? Because that part's a little weird. So if you can kind of visualize this Z, right, it's on the y-axis, it has to do a quarter turn landing on the x-axis. In order for Z to travel clockwise, it needs to be in the positive. Okay, so same thing. Let's find the slope from the origin to point B. So from the origin to point B, I went up 1, right 1, 2, 3. So the perpendicular slope, right, is going to be 3 over 1, the reciprocal, and I'm going to take the opposite. So I want my perpendicular move is now going to be from the origin, go down 1, 2, 3, right 1. That puts me at B prime. And now I can connect my points. And again, you can connect, we kind of can see that connection with point Z. Z was on the y-axis, now it's on the x-axis. That's a 90-degree rotation. That works out. And I'm traveling clockwise, right? I'm going from 12 to 3. I'm traveling clockwise. That checks out as well. How are we doing? How am I doing on time? I have 10 minutes. I'm going to jump to 3 and then go to 2. So 3 is 180 degrees, right? And if this one's about the origin. Again, we don't need a direction. So for 180, direction doesn't matter. Because 180 counterclockwise is the same as 180 clockwise, right? So if you think about an 180 degree angle, what does a 180 degree angle form? Or create? I don't know if I'm making sense. Go ahead.
Straight line.
Yeah, a straight line. So we want to find the slope from our point, but then we want to use the same equivalent slope with the opposite signs to get the other point. I know that doesn't make sense. Let me see if I can make it make sense. So we're going to, I'll start alphabetically. Let's start with point C. The slope from the origin to point C, I went up 0, left 2. So I want the same slope, but I want it to be opposite signs. In other words, 0 over negative 2 is 0. So 0 over positive 2, instead of going to the left, now I want to go to the right. That's C prime. 0 over positive 2 is still 0. These slopes are equivalent because I'm on the same line, right? I'm creating a straight angle. So the slope from, let's do L. The origin to L. So from the origin to point L, I'm going up 2, that's positive. And then I'm going left 1, 2, 3, 4, 5. Up 2, left 5. I want the same slope. So I still want 2 over 5, but now I need to consider my signs. So a positive divided by a negative is an overall negative slope. This time I want the negative in my numerator and the positive in my denominator, which is still going to give me a negative slope, but it's going to get me on the other side. So from my origin, I'm going to go down 2 and right 1, 2, 3, 4, 5. There's L prime. Can you guys kind of envision here how L, the origin, and L prime are all on the same line? They're forming that straight angle. Can you kind of see that? That's how you can check your work. I'm just going to erase it so it doesn't make our page too confusing. Let's do the same thing with the slope from the origin to W. So from the origin, I'm going down 1, 2, 3. That's a -3 because I went down. And left 1, 2, 3, 4, 5. Left 5. So think about another movement, right? A negative divided by a negative is an overall positive slope. So isn't a positive divided by a positive an overall positive slope as well? Right? So instead of going down and left, I'm going to go up 1, 2, 3 and right 1, 2, 3, 4, 5 for W prime. And I can connect my dots here. Right? And you can connect any of your points here. You can see that C to the origin through C prime create that 180-degree straight angle. I can see it with W through the origin to W prime. You guys kind of envisioning that? It might be helpful to do that. I thought I saw a hand. Yes?
Can you just do it without having to show that stuff and just, like, visualize it?
Like going back to the rules?
Yeah.
Or you're saying, do you have to show what I'm doing in red?
No, like, on the, like, for C, can't you just be like, it's just 2 away from the origin? You don't do it like that.
You could. It's easier when you have points on the x-axis or on the y-axis, but when you have other points, I think it might be helpful to write the original slope from the origin to the point, and then either the same slope if it's 180 degrees, or a different version of the same slope versus the perpendicular slopes. Yeah. Yes. Do you guys want to see one more? I can do number 2, which is 90 degrees counterclockwise. Or do you think you're okay? Okay, I'm gonna, if you think you're fine, you can go ahead and try it on your own. For the purpose of the video, I'm gonna stop. We have 4 minutes. But I can show you my answer. Let me stop the recording. I want to make sure it's not too long because then it takes a while to upload. I'm going to do it here quietly on my own, meaning like not explaining what I'm doing. If you want to, feel free to check in.
It's still recording.
Yeah.
What the heck?
Oh no!